Hey class, this is the first problem on that Chapter 14 AP problems list that I gave you. There are two of them, so I'm going to do two screencasts so you don't have to listen to all of it at one time. You can take a break in between. So let's take a look. In a study of kinetics, the reaction represented above followed the data were obtained from 298 Kelvin. We have 4 experiments. We have three reactants. Notice it says for letter A, for the data given above, determine the order of the reaction for each reactant listed below. Show your reasoning. Okay, so I'm going to do this in the standard way that we've always done it. What I'm going to do is I'll start on the left-hand side. We'll start at bromide, and I'm looking for an experiment, 2 experiments where bromide changes, Br minus changes, but bromate, Br03, and H plus does not change. And clearly that's experiment 2 and experiment 1. So I have the change of bromide at 2, or 0.002, 0.001, yet this doesn't change and this doesn't change. That means that the rate change from experiment 1 to experiment 2 is based solely on bromide. So it looks like this. I put experiment 2 over experiment 1. Okay, I do that so that I get a whole number. So I got experiment 2, that looks like this, over experiment 1, this is for bromide. All of that is to some exponent, I call x, and then that equals the rate. So for the rate over here, I get 5.0, and if these two are at the same exponent, then I don't have to even put the times 10, because it would work no matter what. So I get that. So for here, then, I get 2 to the x, because 0.002 divided by 0.001 is 2, equals, and then 5 divided by 2.5 is again 2. So x equals 1. So here I have first order. Okay? I'm going to erase all of this in a second. So let's before I erase all of that, let's take a look. I'd like to do bromate next. So bromate is Br03, and I'm looking for a place where bromate changes, but the other ones do not change. And it looks like I found it. Looks like if I take experiment 3 and experiment 1, that I get this bromide doesn't change. Bromate goes from 0.00500 to 0.00750, and H plus doesn't change. So that means that we're talking about this rate for experiment 1 and this rate for experiment 3. So I'm going to do exactly the same thing that I did before for bromide. I'm going to do it for bromate. I'm going to erase this so that you had time to write that down. And I'm going to go 0.00750 on top. This is experiment 3 over experiment 1. And 0.00500, all of this is to some exponent. This is what we're looking for. And the rate looks like it's 3.75 divided by 2.50. So that would be the rate 3 over rate 2. When I divide these two, notice that I get 1.5 y equals, and then this one again is going to be another 1.5. That means that y equals first order. So far, 2 out of 3 are first order. Okay? Continuing on, I'm going to do the same thing for H plus that I did for the other 2. Let me get rid of all of this stuff here so I can find 2 experiments where H plus changes and Br minus and Br03 does not change. So it looks like I'm going to go experiment 4. Nope, that's not going to work. Experiment, well, 4 has to be one of them because that's one where H plus changes. So that means I might as well go. Now this is going to be the part that's a little confusing, but I might as well go experiments 3 and 4. And the reason why I picked that is to get rid of bromide. Notice that This changes, it doubles, right? Here, this one doubles, and this is the one we're looking for. And notice what happens here. If I move this to there, that means I change that to a -4. I tell you what, doesn't matter. Let's keep all the exponents and everything in. So watch what I do here. This is actually pretty slick, just because we know what the order is for this one. We know that this is first order, so that's going to make a difference. So what I do then is I take my experiment 4 divided by experiment 3. That means 0.200, this is for hydrogen, okay, divided by 0.100. This is some exponent, this is the one we're looking for, but that also equals 0.01500 over, now this one right here is for bromate, 0.0075. Okay, I automatically know this is going to be 2. This one here is going to be 2z. And then look what happens for the rate. Now the rate is 3.00 times 10 to the -3rd. And all of that's going to be divided by 3.75 times 10 to the -4th. So we're going to get a different number here. Okay. So here's what I'm going to do. I notice that 3.0 times 10 to the -3rd divided by 3.75 times 10 to the -4th actually equals 8, like this. So if I want to get all of these together, I divide, now check this out, I divide here and here so that my 2z now equals 4 and my z equals 2. So that makes this second order, and here's how I got that. Because this one we already know, like that, I can divide it by the rate to get rid of it, and that's how I got my 4 here. So 2 to the z equals 4 means z equals 2. Okay? So once I get this, my next question is, what is the rate law for the whole equation? So I write the rate law like rate equals K bromide minus to the first, bromate minus to the first, and H plus to the second. So first, and second. Determine the value of a specific rate constant for the reaction. Okay. Include the correct units. Excuse me. So for this, just use experiment 1. Rate equals all of this. I'm solving for K. So K equals rate divided by BR minus to the first, BrO3 minus to the first, H plus to the second. And now I just plug in the numbers for the first rate, for the first experiment. And it looks something like this. This is molarity per second, I believe. Yep. Divided by, and now the rest of these are molarities. So that's going to be 0.00100. Oh, let me put the units in so you can see what's going on. Oh, okay, I just screwed the whole thing up there. Let's try that again. 0.00100 molar. This one is 0.00500 molar, and this one is 0.100 molar, but that's squared. Okay. After I put all of this into the calculator, and I get a number, and the number looks like this. So 5,000, and that's going to be, now I get rid of one of these like that, but this one's squared, so that still leaves 3. So you can put 1 over molarity cubed times seconds, or you can do like that with the correct units. Okay, I think that's it for the first one. Thank you for paying attention. Let me know what questions you have.